Hello everyone, welcome back to the channel. So yes, today we will be continuing upon the series of the CP-31 sheet by the TLE Eliminators, and we will be solving the problems rated 1800. Okay, so today we will be solving this problem called money buys happiness. Okay, so yep, let's take a look. I have already made the videos on the first two problems. uh, Definitely check them out and try to solve those problems as well. So yep, yeah, so let's take a look at the problem. So so the problem states that being a physicist, okay, so there are timestamps below the video. If you have tried this problem on your own and have a thorough understanding of the problem statement, you can directly skip to the solution part. Okay, so for the next m months, so being a physicist, Charlie likes to plan his life in simple and precise terms. For the next m months, starting with no money, Charlie will work hard and earn X pounds per month. For the ith month, 1 less than or equal to I less than or equal to M, there will be a single opportunity of paying cost CI pounds to obtain happiness HI. Okay, so borrowing is not allowed, strictly not allowed, and money earned in the ith month can be only spent in a later jth month. Okay, j greater than I. Okay, so since physicists don't code, so help Charlie find the maximum obtainable sum of the happiness. Okay, so by reading the problems, do you feel that this is kind of like a knapsack problem where your like weight of the your sack is like not fixed, it is getting larger and larger month by month? Okay, so let us take a look at that problem actually first of all. Uh, so here is the knapsack problem. Okay, so for those of who are not familiar with the knapsack problem, I recommend you to uh, get familiar with it. I assume that most of you are. Okay, so basically this is the problem. There are two versions of this problem, named the knapsack 1 and the knapsack 2, and this is the atcoder contest of DP, dynamic programming. There are 26 problems and they are really, really nice. You should definitely check them out. I'll leave the link in the description. I have made some videos, I think, for a couple of the problems from the starting, but yeah. So knapsack 1 and knapsack 2. So this is knapsack 1, and problem statement for knapsack 1 and knapsack 2 are similar, just the constraints differ. Okay, just the constraints differ. So here constraints are up to 100, n is up to 100, and weight is up to 10 to the power of 5. So for knapsack 1, you can write O of n w n dot w solution and memoizing it with dp. Okay, memoization using dp, you can write O of n times w solution. Okay, so but in knapsack 2 problem, okay, where did it go? Knapsack 2 problem, you notice that we can't write O of n w solution, O of n into w solution, right? So it will be 10 to the power of 11 and it won't fit into our 2 seconds time limit. So here what we do is that they have increased the constraint. Okay, they have tightened the constraint on the w, they have increased it, but they also have decreased the constraint on values of the objects, right? So here it was 10 to the power of 9, but here it is 10 to the power of 3, right? So here in knapsack 2 problem, we write knapsack 2 problem, we write O of n into Vmax solution. This Vmax is basically the maximum value that you can achieve, right? So maximum value that you can achieve will be just sigma over all indices, so summation over all indices value I, right? So each of this value is up to 10 to the power of 3 and our n is less than or equal to 100. This Vmax can go up to 10 to the power of 5 and this n is up to 10 to the power of 2. So this can fit in our 2 seconds time limit, and this is basically the thing. So there are two versions of this problem and both are solved with a slightly different logic. Okay, so our problem, in our actual problem, money buys happiness. So let's take a look at it. Here that they have given that it is guaranteed that sum of h over all test cases doesn't exceed 10 to the power of 5. So here m is up to 50 and summation hi doesn't exceed 10 to the power of 5. Then can I write O of m into h solution? Yes, I can definitely write it and it will definitely pass the constraints, right? The time limit of 3 seconds. So like this kind of constraints reminds us of the knapsack 2 problem. Okay, so that's the thing. So I will briefly discuss the knapsack 2 problem here. Okay, so not briefly discuss actually, uh, so there are multiple ways to write DP, dynamic programming, related to the knapsack problems. So let me show you some of the ways. Okay, so here is one way of writing knapsack 2. Here's one way to write knapsack 2. Okay, so I have many tabs open. Okay, what did I do? I opened problem statement, is it? Oh no. A real absence of mind. So this is one type of solution and this is one type of, not solution, actually it's a code. So this is like writing the recursion, and basically that is how the beginner coder writes the knapsack code. So he will write one function and basically do all the stuff in that function. Okay, so this is for not picking up that value and this is for picking up that value. Okay, so that's basically related, something related to the dynamic programming, knapsack problem solution. But see here it takes execution time of 224 milliseconds, but here in this solution, if I write it this way, I'll understand what have I done here. It will just merely take 9 seconds, because as computer architecture states that calling a function and passing arguments to it is type of a overhead. Okay, you don't want to call the function and increase the stack size, and basically you don't want to uh, introduce overhead into the code, and that is how you don't make the function and just tabulate the results like this way and solve the knapsack problems. Okay, so basically idea of knapsack 2 states that suppose from 1 to Vmax. Remember what is Vmax? It is like maximum value that we can take home with the knapsack, right? So for knapsack 2, our we just write dp from 1 to Vmax. So what will be this store? So dp of I will store minimum weight to be filled in knapsack minimum weight filled to be filled in the knapsack such that we can obtain the value of I, right? Value is equal to I. So that is basically what dp of I states here. Okay, So, and finally, if when my all the dp of I values are calculated, I will iterate from j is equal to vmax to 1. So I will iterate in the reverse order, starting from the vmax and to the 1, basically j minus minus. And whenever I found dp of I, oh sorry, dp of j to be less than or equal to w. W is my knapsack problems parameter, that is the maximum weight that I can fill in my sack, right? So that is the thing. Whenever my not whenever, the first time I get this type of thing, I'll just print j, because that is the maximum value that I can achieve in my knapsack without violating this condition, and I will break from that for loop. That is how basically the knapsack 2 works. Okay, so let me show you. Okay, so this is the correct code of the knapsack 2. So okay. Okay, so I think this is the correct code of knapsack 2. Okay, what is this? I don't know. Maybe I know. This is the correct code of the knapsack, and this is the wrong code of the knapsack. I'll explain you the difference. Okay, so this is the input part of the knapsack problem. So knapsack 1, or let's say knapsack 2. So n and w, and for every I is equal to 1 to n, we are given the weight and the value of that object. Okay, so object or that piece or whatever it is, we are given that. Okay, this is okay, this I think is knapsack only, yes. So n and w taking the input, and remember that our first argument in the pair is weight and second argument is value. Okay, so maximum value that I can achieve, I'll just summation over all v of I dot second, basically summation over all the values. Okay, and I will initialize my dp like this is the standard kind of thing. And why L long max by 2 here, why not L long max only? Because I am summing some value, because I'm adding some value to dp of j, and it may cause overflow, right? So to avoid overflow right here, I'm doing L long max by 2, and dp of 0 is equal to 0. That is basically the base case, or whatever it is, trivial case. And I will go for from every index, like from 1 to n. Basically I will iterate over every index, starting from the first index, to kind of minimize the dp values, right? So I want to calculate the minimum weight required to be filled in the knapsack, such that we obtain the values equal to I. I don't, so while calculating these dp of I values, I don't care if my knapsack will be torn or whatever it is. Uh, it won't be suitable to carry this much weight. I'll just calculate it, and while iterating right here, I will check it. Okay, I will check it that if my knapsack is suitable for that weight or not, and if it is, I'll just print that value starting from the ending, right? So that is basically these nested for loops are doing. Okay, so some of you might be wondering that, so basically why am I iterating in the reverse way here, why in this inner for loop? So this is basically, this part is clear, right? So I will iterate from max value to 0, I minus minus, and whenever my dp of I is less than or equal to w, I will output I. Okay, so that part is clear. Now only confusion, or only part to uh, only part remaining to understand is this thing. Okay, so the if conditions in that for loop, and why am I iterating in the reverse way. First of all, let us take a look at the inner if conditions. So if that v plus I dot second, basically this is my value which I'm trying to make. Okay, this is the value which I'm trying to make from that index, right? From when I'm getting to that index, if I want to include that second value, remember v of I dot second is v. So if I want to pick up that object, but if it goes beyond the maximum value, right, then we want to continue. Okay, continue, because it doesn't make any sense, right? We cannot anyways get greater than maximum value, right? So in that case we will just continue. And this if condition, so basically if I can get the lesser value for this inner value, so for this value j plus v of I dot second, so j is like value that I achieve till the I minus 1th index and for every j, and plus v of I dot second plus v of I dot second is the value of the current object. Okay, so if that value is greater than, so dp of that value, if it is greater than dp of j plus v of I dot first, v of I dot first, basically this is the alternative weight that we can make for that value, right? This value, right, for this value, this is the alternative weight that we can make. And if it is lesser than the initial computed value, we'll just assign the previous we'll just assign that minimum value to our dp state, right? So that is basically that if statement doing. Okay, actually, to be honest, I learn new things when I try to explain some problem to you, really. Yes, and so only one question remains here is that, so why am I iterating in the reverse manner? So why am I iterating in the reverse manner? Okay, time to answer that question. So all the code is same, but here I am iterating in the regular, from increasing from like increase, like in increasing order. Okay, so in previous case here it was continue there, but here it is break, because if it doesn't satisfy, then for next j values it won't satisfy. That's why break here, right? Makes sense? Yep, it definitely does. And now comes the most interesting part. Okay, so this is basically the same condition and the same for loop to print the answer. Just I'm reversing the iteration from j is equal to 0 to max value in the second code. So what happens here is that, so let us take a look at this test case. So where, right here, so here in the input section, here, take a look at here. So let's go to whiteboard. So here like n is equal to 3 and my weight is equal to 8. This is the maximum weight that my knapsack can hold. These are the values 30, 50 and 60, and these are my weights 3, 4 and 5. Then what is the maximum value that I can make from here? Okay, I know that it is 90, right? I will take these two items, right? And yep, that's basically the thing. Here it is 90, but so let's run the both of the codes and try to check that if they give correct output or not. So let's run it. So 90, yep, this course gives the correct answer. So correct answer is given by the code where we are iterating in the reverse order. Okay, so let's check for the code which is iterating in the normal, from the to like increase the order. So run. See, it is giving 100. Oh, that's something crazy happening, right? So let's check what is actually happening. So I'll uncomment these things. uncomment these things, and then if I run it, so what I'm seeing here is that, so see, for I is equal to 140, dp of I is equal to 12. Can I achieve 140 value? Yes, I can. 60 plus 50 plus 30, and it will cost 3 plus 4 plus 5, which is 12, right? So which is 12, so dp of I will be 12 for I is equal to 140, but it won't be outputted, because you know that it is not less than w is 8 here. Okay, so we'll go down. See, for I is equal to 30, dp of I states 11. Okay, wait, what is 130 even achievable? Is it achievable? Exact 130, not more or less than that. Okay, is it achievable? No, right? I cannot achieve it. So what is happening here is that it is taking this 4 and 50, like this item, twice. It is taking it twice, and it is taking first item once. So 50 plus 50, 100, and 100 plus 30, 130, right? And that way 4 plus 4 8, and 8 plus 3 11, and that's why dp of I is 11, getting 11 here. But we don't want to include this second object twice, right? And why is getting counted twice? Because we are iterating in the regular manner, like in increasing manner. Why? So I have stated here, if j plus v of I dot second is 130, so basically I'm printing j. For j is equal to 80, for j is equal to 80, if we are iterating in the increasing order, uh, we know that like for this value 80, the result will always result would have been calculated, right? Like before 30 plus 50, right? So it, from some previous combination, that value would have been updated, and if you try to iterate in this manner, you are going to get the wrong results. Okay, you are going to get the wrong results, and that is what I mean, right? So this 30 plus 50 will give you 80, and this 80 plus 50 will give you 30, but we don't want to include the second object twice, right? So that is why we have to iterate in the reverse order, like clear? I hope it is. I tried my best, maybe not, maybe yes. uh, so I tried to explain you how, why we are iterating in the reverse manner. Okay, sorry, reverse manner, to get the correct answer. Okay, so that is basically in the knapsack part. Okay, makes sense? Yep. So that is basically the thing, and let us head towards our original problem. So this problem is kinda me means mostly same. Here my weight is not fixed, so my weight isn't fixed. So basically I am adding x to my weight in the classical knapsack problem, right? I am adding x at every index. So how can we account for that? So let's check. So uh, this is the standard part, as like the knapsack 2 code, this still here as well. And yep, I have explained you why to iterate in the reverse order, and I have explained this part as well. So here, this is the core part of the code. So you know why is this happening as well, right? So yes, uh, so basically, so if you are like on the ith index, from the I minus 1th in month, you are hopping to the ith month, right? So you have done whatever you have gained whatever happiness. This is like cost array, and this is like happiness array. You have gained some of the like costs, you have gained some happiness by paying some of the costs here, and now you are entering the ith month. Okay, now you'll get the money at the ith month, you'll get plus x money at the ith month, but you won't be able to spend it, right? Because it is strictly defined in the problem that your j must be greater than I. Okay, make sense? Yep. So here for every j value, what is j here? Basically the j is basically it is the happiness. Okay, so for every happiness I am iterating it over, like that's the thing. And if while leaving I, so this is while leaving I have got my x plus x for that month, but I cannot use it, then I will check that while leaving this month, for every value j, every happiness value j, if I can add current month's happiness to it, so this is basically the cost related to that. And if for that happiness j, and I am able to bear that cost v of I dot first as well, basically if it is less than I minus 1 star x, why I minus 1? Because you have to spend it in some next month, then you will basically try to reduce the cost needed for that happiness, right? You will try to minimize it. Okay, makes sense? Yep, it absolutely does. And finally, basically if you are able to make the cost like not equal to L long max by 2, basically it is not like the initialized value, then you are able to make that cost out of some paying some costs or whatever it is, or whatever indices, you are able to make that make that happiness, right? So basically you will output that and finally break it. Make sense? Yep, it absolutely does. And yes, I pretty much struggled much on this problem, but yeah, finally I got the correct logic and the correct dynamics of the code, and finally I submitted it and I got accepted. Well, I'm happy, so happy for my solution getting accepted and you watching my video till the end as well. Okay, so yep, thank you again for watching my video. I hope you enjoyed solving this problem and listening to my solution as well. Thank you, and if you learned something new from this problem, please consider liking the video and staying tuned, staying subscribed to the channel. We are real close. We are almost 100 people on our YouTube channel, so that is kind of milestone for me. So thank you for the support you have shown till and will show further. Thank you for that again. Thank you if you are watching till here. I really appreciate your attention span or patience, whatever it is. But yep, thank you. Stay tuned, and I will be covering all the problems from this TLE Eliminators CP sheet, all the problems in the sense, all the problems from 1400, 1500, 16, 17, 18 and 1900 category. I don't know how long it will take, but I will try to do as soon as possible. I will go from 1800, then maybe 1900, then 1700, whatever level order it is, but I will try to do it. I want to do as much as I can. So thank you for watching video till end again. Thank you.